Hello everybody, today we're going to be proving the midpoint connector theorem for triangles. So first off, we got our triangle here, BAC. Now I want to draw two midpoints, one on BA and one on BC. So I'll draw one right here, name this one M, and I'll draw one right here, and name this one N. I'm going to draw a line through it. So now, since these two points are the midpoints of their respective segments, this side is going to be equal to this side, and this side is going to be equal to this side. Now, I want y'all to notice that we made two triangles here. One is this one, and one is this one. Y'all see that? Okay, good. Now, we're going to be trying to prove the midpoint connector theorem for triangles in this example. And in order to do that, we're going to need to show that MN is 1/2 of AC and that MN is parallel to AC. So in order to do that, in conclusion, we're going to need to prove that this triangle is similar to the bigger triangle. So BMN is similar to BAC. Okay, so now we have this side BA, right? And BA is made up of two segments, BM and AM. Now, since these two segments are equal, you can say that 2BM is equal to BA. So using that, you can make a ratio of 1 to 2. Now, using common logic, we can say that since angle B, the one right here, is part of both triangles, then it is equal to itself. This is also part of the reflexive property. Now, the last part of this similarity is BC and BN. So BC is made up of the two segments BN and CN. Now, using the segment addition postulate, you can say that BN plus NC is equal to BC as a whole. And using the same logic that we used in BA, we can say that BN multiplied by 2 is equal to BC as a whole. So this leads to the ratio of 1 to 2. So now we proved that BMN is similar to BAC due to the SAS similarity postulate. Now, BA and BC have the same proportion when compared to BM and BN. So BM over BA, so basically this side over this whole side, is equal to BN over BC, so this side over this whole side, which in conclusion is equal to 1/2. So as a conclusion of what we've done so far, we proved that the proportion of BM to BA is 1 to 2, that the angle B is part of both triangles and therefore is equal to or congruent to itself, and that the proportion of BN to BC is also 1 over 2, showing that BMN and BAC are similar by the SAS similarity postulate. So the definition of similar triangles state that corresponding angles must be congruent and all the sides must share the same proportion or ratio. So using that definition, we can state that BM, or this angle, is equivalent to angle BAC. So these two angles are indeed congruent because they are corresponding. So since we know that these two angles are congruent, we can also say that using the parallel line postulate, we can finally state that MN is parallel to AC because these two angles are congruent. Now that we proved that this line is parallel to this line, the last part of this proof is to show that MN, this line, is half the length of AC. Going back to the definition of similar triangles, we know that all the sides, all the sides must share the same proportion or ratio. So since the proportion of BM to BA was 1 to 2, and the proportion of BN to BC was also 1 over 2, we must state that the proportion of MN to AC should also be 1 to 2. Or, in other words, MN is half the length of AC. And that, in conclusion, is the proof of the midpoint connector theorem for triangles.
Okay.
Thank you all for listening, and you were a great audience, and I'd like to congratulate you all.